think it's okay. Yes, it is okay. Sorry about that. So yes, I copy the base and subtract the exponents. From 13, I subtract 11, which is 2. And the answer is?
Negative 6 times negative 6.
1036.
Very good. Okay, let's look at 70. 70 is x to the 8th, y to the 6th over x, y to the 5th. Copy the base. What happens to the exponents?
Subtract that.
Correct. From 8, I subtract,
1.
and I get,
6.
copy y. From, from,
6.
yes?
You subtract 1. Oh.
From the power of the numerator, which is,
Oh. 6 minus 5.
yes, which is
1.
correct. So this is the final answer. Right? Okay, let's look at 72. I feel that we are not there yet. B to the 7th over 27ab squared. Okay, what will be the first step? Nine and 27 have a common factor of
3.
even 9.
39. Yeah.
1, 3. So I have 1/3. For A, I copy the base, what happens with the exponents, and what do I get as the result?
Subtract 1 from 4.
So I have,
3.
perfect. Copy the base for B,
7 minus 2.
very good, which is
5.
perfect. Okay, I think one more, and then hopefully you agree with me that we can go on. If not, we'll choose more problems. Let's say 116. 2x to the 6th, y squared. Everything in parentheses raised to power 5 over negative 32, x to the 20th, y to the 10th. And let me tell you, after you copy it down, let me tell you what I would like to do. Ready? I would like to simplify or say y to the 2nd power divided by y to the 10th. Copy the base and subtract 2 minus 10. Is it a yes or a no?
No.
Why?
Because you got the exponent in the parentheses.
Of course. The top is not simplified yet. I can work from inside the parenthesis before I apply the power by the order of operations. Very good, thank you. All right. So, I copy the denominator as is. And now please tell me what to write for the numerator. Yes, which is, we should remember, maybe this is the time after we finish this is the time for me to give you a little list of things to not memorize, but the more we use them, the more we should be accustomed to them. Okay, so 2 to the 5th is 32. Copy the base. What happens to the exponents? X to the,
30.
thank you, multiply by y to the,
10.
very good. I start with the numbers. Don't forget to write the 1. If you don't write the 1, you may be tempted to say or think that it's a 0 in there, which is not the case. So I have 1 over negative 1. 1 over negative 1. So this is negative. Copy the base. What happens to the exponents of x?
10.
Awesome. And what about y?
It's y. Y.
It goes away.
Exactly, because they are the same. Or y to 0, which is
Y.
1, assuming that y is not 0. In the same way, I write the 1 as I did it with 32. It's the same procedure. 32 and 32, 1, 1. Y to the 10th and y to the 10th, 1, 1. Right? So this is the final answer. Although I think we understood this, I still believe that there is a need for a lot of problems or work on other problems at home. Is that okay? Can we move on? This was only section 5.1. Any questions for me?
Yeah, actually.
Yes, please.
So can we go back to 2 problems? For a second?
Yeah.
Move the pages.
Oh, I mean the same page?
Yeah, it's on
Or-
the same page.
okay.
So number 68 right there.
Yes.
Why did you go from? I might have answered my own question.
I was going to say,
Yeah.
I have to copy the base.
Right.
Otherwise, I can subtract exponents unless they have the same base. If they don't have the same base, I can't do anything. Here I had, like, initially by mistake, I put the 1, I can't do anything.
It's just weird because when you see a fraction, you think division, but you're not dividing at all. You're just subtracting.
Awesome question. Hold your thought. Hold your
That's
thought.
what confuses me about that.
Hold your thought. Very good question. Very good question. Thank you. I hope that I can help you understand things. I really hope that I can make you smarter. But honestly, you make me smarter. And I have a lot of questions coming from students who make me smarter in the sense that I'm more in tune with the students' needs and what I need to present or explain when students ask questions. Does it make sense? I would not know all the little things that I possibly skipped or that I didn't mention or I didn't think of mentioning without your questions. So I thank you every time you ask a question. So I'm going to go back to this -6 to the 13th and the -6 to the 11th, okay? Because it's an awesome question. Here it is. Of course, you don't have to write this. Four, 5, 6, 7, oops, 7, 8, 9, 10, 11, 12, 13. Right? You understand what I'm doing, right? 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Correct? Right? It's like writing -6 to the 11th times -6 to the 2nd power over -6 to the 11th.
Yeah, but I guess the question I'm trying to ask is why wouldn't you just do -6 to the 13th power and then do -6 to the 11th power and then divide the top number by the bottom number?
That's what we did. That's what I did.
So it's essentially the same.
Yes,
Okay.
that's what I did. That's what it means. I divided this by this, and this is 1. So I rearranged power 13 into power 11 and power 2.
Oh, yeah, okay. Got it.
And this is 1. It's like what we just did a second ago with this. Negative 6 to the 11th, negative 6 to the 11th is 1 and 1.
Okay.
Because I take away negative 6 to the 11th from the top and negative 6 to the 11th from the bottom, which is 1. So all I'm left with is negative 6 to the second power. So it's the same thing, done in a different way if you want. And this is a shortcut, meaning copy the base, subtract the exponents.
Okay.
Because that's what the result is, ultimately.
It's just the thing is like I don't feel like I'm dividing in this case because I'm using a shortcut. But
Right.
in reality, I am dividing.
You are dividing.
Right.
You are dividing. But you would not be able to divide if these two were not the same.
Right.
Then you would have had to do exactly what we just do, what we just did with different numbers.
Right. When we share the fraction line.
Yeah.
Okay. All right.
But because they have the same base, I'm allowed to say, copy the base, subtract the exponents. Go directly to the answer.
Okay. All right.
Only because they have the same base. Otherwise, I wouldn't be able to. Okay? Any questions here? Okay. Now we can start this section 5.2, which is on polynomials. That's when we start polynomials. So I highly recommend, as soon as you get the chance to redo the problems we did in class, to work on these problems immediately to cement the understanding that we all have today on the exponential rules. So redo the problems we did in class and then go directly to this immediately. And check the answer in the back and let me know if you have any difficulties with anything. So finally, 5.2, polynomials. There are many different types of polynomials. We basically split them in few categories. Here is category 1, called monomial. A monomial is one term, also called one product. If there is addition or subtraction in an expression, that's not a monomial. Here will be an example, or examples. Negative 2x to the third, another example. 4x squared y z. Another example. Negative 7t squared. All these are monomials. One term, one product. It can have one factor, it can have two factors, it can have three factors, it can have one variable, two variables, three variables, whatever you want. It can even be 7 alone. 7 alone is a monomial. Doesn't have variables. So what? Still a monomial. One product, one term. The second category, of course, will be, what do you think?
Binary.
Exactly. What a binomial will be. Of course. Added or subtracted. I put that in parentheses. Added or subtracted. Of course, a sum or a difference of two products. In another way of writing it. A sum or difference of two terms or two products. Okay, what will be the next? What do you think? Very good. It is a trinomial. What would this be? All of the above, but this time?
3.
Yes. added or subtracted, or a sum or a difference of 3 products. Okay, we are not going to go beyond with names, beyond polynomials. However, when I say a polynomial, without specifying the polynomial, you will not know what I'm referring to. Because a monomial can be a polynomial, a binomial trinomial can be a polynomial. Normally when we call them polynomials, we mean 4 terms or more. Okay? But all of the above are polynomials as well. So let me give you an example, a couple of examples of binomials, trinomials, and polynomials. I should have done that here. So a binomial. Examples. Let's say 2x plus 1. This is a binomial. Can you give me one? Can you give me an example of a binomial?
Could be
2a minus 3b. Can you give me another example of a binomial?
A minus 2b.
That's it. What about 4x squared minus 3? I can make any combinations I want. 4xy minus 3z squared. As long as I see 2 products or 2 terms added and subtracted, that's a binomial. Can anyone give us examples of trinomials?
Be like 2x plus 3y
Yes,
equals, plus 4.
that's it. That's a trinomial. One more. Let's say 4x to the second power minus 3x plus 7. Are these trinomials?
Yes.
Yes. Okay, let's look at polynomials. Although all of the above are polynomials, in general when we talk about polynomials we mean 4 or more. Let's say 5x cubed minus 3x squared plus 7x minus 10. Is this a polynomial?
Yeah.
Is it a monomial?
No.
It's a sum of how many monomials? Or sum or difference? 4 monomials. Now, we need to talk about what it's called a degree. Of a polynomial. For a monomial and the general, anything else. So the degree of a polynomial depending on if it's monomial or anything else. Number 1, why is it so important? Why do I need to know for a monomial, binomial, trinomial, polynomial? Why would I need to know the degree? The degree tells me a lot about it. If it's degree 1, then it would be a linear function. If it's degree 2, it will be a quadratic function. If it's degree 3, and so on and so forth, everything changes. The degree is the key. If you say, think of a polynomial degree 3, I will think of a graph that looks like this. If you say, think of a polynomial degree 1, I'll say, okay, it's a line. So the degree is extremely important, not just for that, identifying the type and identifying the graph or graphing such a function later on. But it will always tell us if we are solving an equation, how many solutions to expect. For example, if you give me a polynomial that it has degree 3 and you say set it equal to 0 and find solutions, I'll have to find 3 solutions. If you give me a polynomial degree 4 and you say set it equal to 0 and give me the solutions, I'll give you 4. So it's also connected to the number of possible x-intercepts that that polynomial has, and so on and so forth. So what is the degree? We don't even know what it is yet. Okay, so I'm going to go back to our examples for monomials. When we step or determine the degree of a monomial, we only look at variables. Can you please tell me how many variables does this monomial have?
2.
Variables. -2 is a number.
1.
1. So it only has one variable. What is its power? So this monomial has degree 3. Moving on to the next monomial. How many variables does it have?
3,
And what is the power of x?
2,
What is the power of y?
1,
What is the power of z?
1.
Add them up. Nothing concerning the number. Add 2 to 1 to 1. That would be the degree. How much? Yes, indeed. The next monomial. How many variables does it have? 1. What is its degree?
2,
So this monomial has degree 2. Last one. How many variables does this monomial have?
1,
So then the degree is
0.
exactly. I'm not saying the power of 7. It's a totally different story. I'm talking about the degree of the monomial. So the degree of the monomial is 0. So in summary, how do I find the degree of a monomial? I add the degrees. I'm sorry. I add the exponent or the power. I add the powers of all variables. I add up the powers of all variables. And that will give you the degree of the monomial. Okay? We add up the degree, the powers or the exponents of all variables. Okay, let's look at now anything, anything else. Anything else? Ready? Good. This is a binomial. I want to determine the degree of this binomial. First, I look at the first monomial. What is the degree of this monomial?
It's 1,
1. Very good. Awesome. I look at the next monomial. What is the degree of this monomial? None. So this one has degree 1. This one has degree 0. I'm not adding them up here. Only in a monomial I add up the exponents of the variables. Here I only choose the highest. You correctly identify degree 1 here. You correctly identify degree 0 here. Then the degree of the whole thing is?
1,
Yes. Okay, let's look at this. The degree of 2a.
It's 1.
1. The degree of 3b.
It's also 1.
So what is the highest of 1 and 1? Okay, let's look here. What is the degree of the first term or the first monomial?
2,
What is the degree of -3?
0,
What is the highest between 2 and 0?
2,
So this is degree 2. Last one. What is the degree of this monomial?
2,
Yes, awesome. What is the degree of this monomial?
2,
What is the highest number between 2 and 2?
4. No, 2.
2. So this is how we determine the degree of a polynomial. We choose the highest degree of any monomial. Okay, choose the highest degree of any monomial. So in other words, when I find the degree of a polynomial, I identify the degree of each monomial and I choose the highest. Any questions? Any questions?
Yeah, I got a question.
Yes,
Is term and monomial
the same. Yes,
Okay.
yes, yes. Okay, now I would like to establish the degree of this. What is the degree of the first term? What is the degree of the second term?
1,
What is the degree of the third term?
0,
So now I'm choosing the highest between 2, 1, and 0. So degree,
2,
okay, what is the degree here?
2.
Because the degree of this is 2, the degree of this is 1, and the degree of this is 0. Okay, final question for this one. Very good. Because degree of this is 3, degree of this is 2, degree of this is 1, degree of this is 0. I must choose the highest because this is a polynomial with 4 terms, not a monomial. Any questions? Are we okay so far? Yes? Okay. Let's look at the following trinomial. I'm going to ask you, is this a trinomial?
Yeah.
Yes. What is its degree?
2.
Awesome. Is this trinomial in descending order? In other words, from the highest to the lowest, descending order of the variable? No, it's not. Let's rearrange it. This is extremely important. All polynomials should be kept in descending order of the powers of the variable. So how would you rearrange 4x minus 7x squared plus 8 equals? Squared, very good. Yes, yes, very good. We need the polynomials to be in descending order. Oops. I don't need this. We need polynomials to be in descending order of the powers of the variable, not just because it's easier to identify the degree, but also because we have to identify the leading term and the leading coefficient. So these two are extremely important for each polynomial. You will see later in math what the leading coefficient says about the polynomial, what the leading term says about the polynomial, and so on and so forth. Okay, so looking at these 3 terms, I'm going to ask you, common sense, which of these 3 terms is the leading one? The one that gives the degree, the one that is more powerful, the one that leads. Which one? Please read it. That's it. That is the leading term. Is the term that is the most powerful. Is the term whose degree gets transferred over the entire polynomial. Very good. This term has a coefficient. Therefore, its coefficient would be called the leading coefficient. Can anyone identify the leading coefficient? Coefficient has nothing to do with x.
2.
Say again?
2.
So the leading coefficient.
Negative
One.
7.
-7.
I don't
I'm thinking of the power.
understand.
So the coefficient has nothing to do with the variable. The term called leading term is the one that leads. It's the one that is in front after you rearrange it in descending order, one that gives a degree, and so on and so forth. It has a leading coefficient. Why it needs to be understood and identified is for later in math.
So once you have found the leading term, the rest of the variables don't matter. The rest of it don't matter.
Yes, but they don't have names, and they don't signify much. They do matter, of course, but they don't have specific names that we have to
Okay.
attach to.
Now, do you only put it in descending order to find the leading term and the leading coefficient, or is there other benefits? to doing it
Yes.
that way?
A lot.
Okay.
Yes, awesome question again. So here's an explanation, or just a couple of reasons. When we get in chapter 6 to solve quadratic equations by factoring, if we don't arrange the polynomial in descending order, we will not be able to factor. Second reason, if we don't have the polynomial arranged in descending order, we will not be able to complete the square later on in O12. If it's not arranged in descending order, I will not be able to use the quadratic formula because I will not identify correctly A, B, and C for the quadratic formula. Solving equations, and so on and so forth. Factoring, when we talked about rational expressions in chapter 7, if polynomials are not all arranged in descending order, I will not be able to simplify. So this is crucial. Descending order for based on the powers of the variable, extremely important. Very good question. Okay. Let's make up some polynomials, or we can choose, because I like to discuss degrees and so on and so forth. I may not find what I'm looking for right here. Yeah, I have to make a couple of them up. I don't see what I want to work on for a minute. So let's say I have 5x minus 3 x to the third plus x squared minus x to the fifth. What type of polynomial is this? Because remember, we know monomial, binomial, trinomial, polynomial. It's a polynomial because it has how many terms? It has 4. It must be polynomial. Good. What is the degree of this polynomial?
5.
Degree 5 indeed. So then you will tell me how to rearrange it, because obviously it's not arranged in descending order of the powers of the variable.
Negative 5x. Negative x5.
X to the fifth, very good. Yes?
Minus
Yes?
3x to the power 3
Awesome.
plus
Yes.
x squared
Yes.
minus plus 5x.
That's it. Now, in chapter 6, I'm going to ask you this. Are there missing terms from this polynomial? And you should say, how do I know? How would I even think of missing terms? Here is how we think of missing terms. The degree is 5, correct? Is there a term with x to the fourth? Is there a term with x to the fourth in this polynomial?
No.
So that's a missing term. We need that in chapter 6. In chapter 5 at the end, I'm sorry, actually, when we divide polynomials. Is there a degree 3?
Yes.
Is there a degree 2?
Yes.
Is there a degree 1?
Yes.
Is there a degree 0?
No.
That's another missing term. Good. Now I would like you to determine for me the leading term.
It's the first one.
Yes, it's negative x to the fifth. The leading coefficient, please.
-1.
Thank you. Later on, not in this course, later on that will mean a lot. It will tell you whether a graph opens up or opens down. That leading coefficient alone. Or if it's this, or if it's this. That leading coefficient alone will tell you a lot about the polynomial. Any questions? Any questions? So these are key terms. Key terms. Leading term and a leading coefficient. Now, combining like terms. First of all, what are like terms? Well, 2x and 3x are like terms. They are. But 5x squared and 7x cubed are not like terms. There is no way I can add or subtract 5x squared to 7x cubed. Like here. Are these like terms? No, I can't combine anything. This is degree 5, this is degree 3, degree 2, degree 1. They can be like terms. I can combine them. I cannot say in my head 5 apples plus 2 apples. Here I can. 2 apples plus 3 apples is 5 apples. Or subtract them if I want to do that. So combining like terms means everything the same except the number outside, which we don't really care about. Okay, combine like terms. Let's combine like terms. Problem 38 on page 328. X squared y plus xy minus y plus 10x squared y minus 2y and plus xy. Well, this looks difficult. It really isn't. We just have to start with the first term and go step by step, analyze and see if we can find the same thing. Can I find an x squared y anywhere? No, no, yes. No, no. So what is the coefficient of x squared y?
1.
What is the coefficient of x squared y?
10.
It's positive 10, right? So positive 1 plus 10 is
11.
11x squared y. So these are accounted for. Then I continue with the next term, and I see xy. xy? No. 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 Yes. What is the coefficient of xy?
1.
What is the coefficient of xy?
1.
They're both positive, so I'll write plus.
XY squares.
Ah, gotcha.
I didn't say that. 2xy.
So these are accounted for. So now I'm getting to negative y and then negative 2y. I can say negative an apple minus 2 apples. It must be negative 3 apples. Now I'm going to ask you, after we completely simplify it, what polynomial is this? What type?
Is it
Trinomial indeed. What is its degree? I don't know. Let me check. What is the degree of this?
1. 2. I think it's 1.
It's 3.
Yeah, so let me tell you, you're probably left the room. So degree, so the power of x is 2, the power of y is 1. So the degree of this is adding. We determine the degree by adding the powers.
Okay.
So this degree is 3. This degree is,
2.
and this degree is.
1.
I have to choose the highest. So I have among 3, 2, and 1. What degree is this?
3.
Indeed, degree 3. 46. Negative 7x squared plus 4x plus 7. They put this in parentheses just to confuse us, but that's okay. We're not confused. Good. So here we're asked to add or subtract polynomials. So let me tell you one more time where we are. We completed all this and including combining like terms. So our next step will be evaluating, which I didn't get. And like terms and degree, we already talked about. So addition and subtraction,